Hello, I'm Akhilesh Amda and welcome to my presentation on advanced process model. So let's start with the presentation. Okay. Coming to our first topic, it's rework and repetition. When designing a process, we often encounter situations like part of the process may need to be repeated or reworked because uh, to represent such situations, we can use a loop symbol. So that indicates a certain set of activities may be repeated until a certain condition is satisfied or not. So one way to model this uh, loop activity is by using XOR gateway, the XOR gateway functionality is like it splits the process flow into two parts, one for the normal flow and one for the rework flow. So there might be another few approaches which we can expand to this next extent to repeat the activities. This subprocess is marked with a loop symbol that indicates the repeated activities and all, with the condition when the repetition should end and conditions which are need to be satisfied and all. So if a subprocess contains specific activities which include decision activity and any other activities, for example, a decision activity subprocesses which are need to be repeated, then we need to repeat the process without any decision activity. And the loop symbol represents a structured cycle, which means that there's only one entry point and only one exit point. However, there might be some times where there may be more than one entry and a one exit point, but mm, then there should not be any repetition block. So in such cases, the cycle is unstructured and it's unstructured and cannot be represented as a simple loop symbol. There are some additional conditions which we need to follow. And next, parallel repetition. Coming to the first method. In the business process modeling, we often repeat the same task multiple times, right? We often repeat same task multiple times, such as getting quotes from multiple suppliers. Uh, so these are the situations we use parallel repetition. So one way to represent this parallel repetition is to lose a loop activity where each instance of the task is executed sequentially. However, this can be uh, impractical, and when the number of repetitions become large, and no, it's not practical in the real life scenario. So it to address these kind of issues, business process model notation provides a structure called multi-instance activity, which allows us to do the same task or perform the same task uh, and to execute them multiple times concurrently. I mean parallelly with a dynamic number of repetitions. So coming to the next point, next slide. Uh, so to illustrate a parallel repetition, let's consider a procurement process. Let's consider an example where we need to obtain quotes from multiple suppliers. Instead of using a loop activity, we can use a multi-instance activity to represent the task because obtaining quotes from each supplier using a multi instance activity would be a better choice for us. And we first retrieve the list of suppliers. First, we retrieve the list of suppliers and pass it to the multi-instance activity. Then the number of activity instances should be created is determined by the suppliers in the list. So to handle the dynamic list of suppliers, we can update the list in an organizational database and database queries, and by also contacting the suppliers. This way, the process model does not need to be revised every time, right? The model will be not revised every time, and the list of suppliers changes as well. These kind of illustrations can be done in the parallel repetition. Then also we can also annotate the multi-instance activity to specify the minimum number of instances that need to be completed before passing control to the outing architecture. So second one, uncontrolled repetition. So the this kind of a uncontrolled repetition is used when we need to execute the same activity multiple times concurrently. For example, let's say we need to obtain quotes from multiple suppliers in a procurement process. Instead of creating a separate task for each supplier, we can use a multi-instance task marked with the three small vertical lines at the bottom. This does not reduce the size of our model, but also allow it also allows us to work with a dynamic list of suppliers that can change on the daily basis or instance by instance basis. We can even specify the number of instances that need to be complete before passing the control of the outgoing architecture. This is useful when it comes to some large number of suppliers where we need to deal with the large number of suppliers and we need to get certain codes to make decisions and all. So let's move to the next topic uh, for handling events. So our next topic is handling events. In a process, events are used to represent something that happens instantly, right? There are two types of events: start event and end event. Start event represents beginning of a process, and end event represents completion of a process. So intermediate events which occur during a process, like when an order confirmation is received before proceeding with the shipment, when an intermediate event occurs, this is an event. So once the event occurs, the token moves past the event instantaneously. Intermediate events are represented as circles with double borders. They are used to show whether the process needs to be paused or interrupted or to wait for the response from the system. So message events. So in this message events, we will be discussing about uh, the events which are used to capture interaction between our process and other parties. Like message events includes start message events, end message events, and intermediate message events. For example, a start message event with an empty envelope can be used to trigger new process instance when a message is received, and as well as an end message event signal that process conclusions upon sending the message, and intermediate message event signals the receipt or sending a message during the execution of process. This is the whole process. So let's discuss with an example, right? It gives us clear explanation. For example, in a loan assessment model, activities like returning the application to loan applicant, or receive the updated application. We can use the intermediate send and receive message events, since they do not represent any work, right? But rather the mechanics of sending or receiving a message. So if a send activity is immediately followed by an untyped an event, we can replace this with an end event, right? Uh, it is also merely used to send a message after which the process concludes. So it's important for us to note the start message event. It's not an alternative notation for an untyped start event followed by an received activity, because in the former situations in the former case studies, uh, process instances start upon the receipt of a specific message, while in the later in the present generation, process instances may start at any time, after which the first activity requires a message to be received. This is the note to be noted. And coming to the summary, message events are useful notations to represent interactions between a process and other parties and so temporal events. Um, in addition to the message events, we have temporal events which specify timer events as triggers for start events in a process model. And timer events indicate that process instances start upon the occurrence of a specific temporal event, such as, for example, every Friday morning or every morning. Timer events can also be used as a intermediate events to capture the need for the temporal interval to elapse between a process instance that can proceed. So to indicate a timer event, we mark the event symbol with a watch inside the circle, right? To We indicate like that, and it's important to note that timer events are catching events only, meaning that the process does not generate the timer, but rather reacts to it since a timer is triggered outside the control of the process, right? So, for an example, that is driven by three. Let's take a three-driven temporal events. It start with 3 weeks prior to the call over date. So continuing to the first week prior to the call over date and concludes the day of the call over. So to model these events, we need to start. We need one start and two intermediate timer events. Okay. From a token of semantics point of view, a token capturing a new instance is generated every time uh, when 3 weeks prior to the call over date. And once the first activity prepare call over list has been completed, then for example, the token is sent through the incoming arc of the following intermediate timer event. Then after prior to the first week and then the event becomes enabled, the token remains trapped in the incoming and the temporal event itself occurs when it is in 1 week prior to the call over date. Once all these activities happen, the token instantaneously traverses the event symbol and moves to the outgoing architecture. So racing events. In the business process modeling, events can be used to capture external factors as well. That external factors can be uh, like influence the flow of the process. Okay, one most common scenario which we come across is when two external events race against each other. So the first event to occur determines the next step in the process. This is where the event-based XOR split comes in, and which is represented by a gateway marked with an empty pentagon, right? So, for some instance, for time being, let's consider a case. In the case of a insurance quote company, being insurance need to be quote insurance quote need to be sent to the client. The client may respond with either an acceptance or rejection, right? If the acceptance message is received first, an insurance contract will be made. If the rejection message is received, the quote will be discarded. So when the execution of the process arrives at the event-based executive gateway, the XOR gateway, the execution stops until the next message arrives. So whichever event occurs first will determine the way the execution will proceed. Like uh, if if approval from the client, then it approves. It goes to the next process. If rejection, the code will be discarded. Like so, if the timer event occurs first, a shipment status inquiry will be initiated and the execution flow will come back to the event-based XOR gateway. If the message signaling, if a rejection is received, then it will follow the sequential flow that leads to an and all those things. So, you know, as a result, when event-based XOR split can only be followed by an intermediate catching events like timer or message event or by receiving activities because the choice is delayed until event occurs, right? The event-based split is also known as deferred choice. There's no event-based, branches to uh, split and merge the XOR gates. So handling exceptions, how we handle the exceptions. In the business process modeling, exceptions refers to events that cause a process to deviate from its normal workflow. So these events are known as rainy day. So scenarios because they happen frequently in reality and they disrupt the whole process or sometimes it also terminate a process. So examples of exceptions in business include faults such as out of stock, technical fault like database crash or network outage. When modeling a process, it's important to identify and account all possible exceptions that occur because for instance, let's consider if a product is out of stock and order to cash process may need to be interrupted. So in order to order the product from supplier, in some cases there might be process may even need to be aborted altogether if a product cannot be supplied within the given time frame, so the whole process will be terminated. So we can even better prepare for them or develop continuity plans that allow us to respond effectively when they occur. Because having a contingency plan when a original plan disrupts or terminated will ultimately get you the better results. So it helps us to ensure that our process remain efficient, reliable, and effective even if we face some unexpected events. So process abortion, we are sometimes we need to even terminate the process. In any process there can be some exceptions that deviate the process from its normal workflow, and these exceptions can cause the process and even they need to be aborted. No, the simplest way of handling an exception is to terminate the running process and signal an abnormal process termination. This is done by using terminating an event, right? Because which causes an immediate termination of the process instance at its current level or any sub-process level. So, for example, let's consider okay, a home loan application process. If the application has high debts or high liability, the loan application may be rejected and the process will be terminated. The term the terminate event destroys all tokens in the process modeling or in any sub-process because it is necessary to avoid the process getting stuck and before it's necessary to avoid process to be stuck in any sub process because where a token may remain trapped due to high liability or high debts and all. It's important to note that terminating an event is triggered from within a sub process. It's not only cause of the abortion of the parent process but only the sub-process. The terminant event is only propagated downwards in the process hierarchy. So there are some internal exceptions in a business process refer to situations where the process encounters an error or exception due to internal issues that include data input, processing. When an internal exception occurs, the process need to be stopped or restarted to ensure that the error is corrected, right? Before continuing to the next process. So in business process model notation, we can use error event to capture these kind of scenarios. And End error event is used to interrupt the enclosing the sub-process to, and it throws an exception. This exception can then caught by an intermediate catching error event. So all these are attached to the boundaries of this same sub-process. So external exceptions, sometimes there might be events which can interrupt an activity in a process, causing unsolicited exception. For example, seller checking the stock availability of a product for purchase order may receive an order cancellation from the customer, right? There might be some external exceptions as well. So activity timeouts in business process model notation, a timer event can be used to model activities that must be completed within a specific time frame, because it's useful when there is a deadline or completing an activity, because such as approval that might be completed between the before the deadline. Complex exceptions, in business processes, there are some situations when an external event should trigger a procedure without interrupting the activity itself, because non-interrupting events, and they are denoted by dashed double border. For example, let's consider uh, the order to cash process during the stock availability check. The customer need to send the request, right, to update its details. The details should be updated in the customer database without interrupting the stock check. So events of process, an alternative to boundary events is the events of process. An event subprocess is started by an event to enclose the procedure that should be triggered by the event, which would otherwise be attached to the boundary of an activity. The main difference between event subprocess and boundary events is that event subprocess do not need to refer to a specific activity, but the model events can occur during the execution of the entire process. Activity compensation. Compensation is a process that reverses one or more steps that might have already been completed due to an exception or that occurred in the ending sub process. This is done to restore the process to a business state, to close one or before starting the process, sub process that are interrupted. So process and business rules. Business rules are organized for, there are some policies and practices that can be implemented in a process model in different forms. One way to model them is through a dedicated business process model notation event called no conditional event. A conditional event causes activation of its outgoing flow when the irrespective of the business rule is fulfilled. So let's recap the whole presentation. We have started with the topic of rework and repetition, and learn how the model structured loops and multi-instance activities. We have also discussed about the sub-process which can be captured, unstructured repetitions and all. We also triggered with the various types of events such as catching events, throwing events, start event, end event, how the frame message exchange between the pools using the message events and all. Then we also looked upon the exceptions, how to handle the exceptions, such as terminate the process via terminate end event, using catch intermediate events to how to recover a procedure and all. And we also learned about the timeout activities, types of exceptions, activity compensation, how to revert the how to revert the effects of an activity that are completed. So finally, we saw how the business rules can be defined in process models using conditional events, which allows us a process instance to start. So by understanding and utilizing these concepts, we can effectively model and analyze complex business process in a structured and organized manner using business process. method and notation. Thank you very much.